Hello, today we are going to go over the Unit 2, Lesson 9, Physical and Chemical Changes. Make sure that you are trying to answer each question before we move on, so make sure that you're pausing it if need to. If you don't understand something even after we go over it, make sure that you are sending me a K-mail so we can make sure you have a good understanding of that before we move on. Phase changes. Because energy content is responsible for the different phases of matter, substances can be made to change phases by adding or taking away energy. So remember that this is like thermal energy or the flow of heat. So if you look here, if we look at temperature and pressure, depending on the temperature, depending on the pressure, depends if the substance is going to be ice or vapor or if it's going to be that liquid. This graph in particular is for water. And the same thing over here. This is kind of more of a generic one over here on the right. But you can see there is an instance where they can go from gas to solid and then back. Or of course do this gas to liquid to solid that we normally think of. Alright, so this one here, as the heat increases, so that's what this empathy is just going to be heat. So as that heat increases, you're going to see the state of which the substance is in change. So from liquid, it can vaporize and go into gas, or it can cool and go into a solid. Just the same, the solid can heat up and move to a liquid, or it can actually go straight into a gas as well. So the major ones that you can probably think of to go from a solid to a gas would be like mothballs. Mothballs actually give off a chemical that keeps moths and other bugs away out of clothes, and especially if you're not going to be wearing them for a while. So the same thing here, you have, as we add energy going across the top, you go from ice to water. And if you add even more, it evaporates and turns it into water vapor. Or if you remove energy, water vapor condenses into water, and that water can freeze and go into ice. So it all depends on energy being added or taken away from. So physical change. What do we call the process of matter changing from one state to another? Do you think that's going to be a physical change? Or is that going to be a chemical change? So just like we're looking for, so we're looking from water vapor to water to ice, or ice to water vapor. Is that a physical change, or is that a chemical change? If that is going to be a physical change, because the water molecules are still going to be the same, we're just changing the physical state of them. So how can a substance be made to change phase? So if we're going from ice to water, we just have to add heat or energy. And same thing when we're going from water to water vapor, we just have to increase that energy. But now going on the reverse, going from water vapor to water, we have to take away energy. And the same as going from water to ice, you have to take away that energy. So we do a phase change by adding or subtracting energy. So how can a substance be made to change phase? By adding or removing heat. So if you look here, the blue arrows here going down are all removing energy. All the red is going to be adding energy. Alright, so question. Suppose you place several ice cubes in a glass of water that is at room temperature. We want to know what's going to happen to the ice cubes over time. We want to know what happens to the temperature of the water in the glass. And we want to know what happens to the level of water in the glass. And we're going to assume that evaporation does not occur to any great extent. So if we have the ice cubes, and the ice is going to be colder than the water, so the heat energy in the water is going to go into the ice. So the ice is going to heat up, which is going to cause the ice to melt. And at the same time, as the ice is melting, it's going to take energy away from the water, so the water temperature then is going to decrease. But as the ice melts, it's going to go into that liquid state, so it's going to turn into water. So the overall level of water is actually going to increase. Okay, so over time, the ice cubes melt, the temperature of the water in the glass decreases, and the level of the water in the glass goes up. So here we have our example. And as the energy of the water moves into the ice is going to slowly melt and turn into that water. So it's going to phase change into water, and as the ice melts, the water is actually going to increase. So if we had a glass that started out with this much water in it before we added the ice, after all the ice melts, it might be up to this line here, depending on how much ice we put in it. So this, if you look at this glass, the water might have actually started out at this level, but the ice melts, you're actually going to see this line is going to move down, but it's not going to meet that starting point. It's actually going to stop a little higher than that. When bonds between atoms are broken or formed, what type of change has occurred? So now we're going to see a physical or chemical change. So we're going to see those bonds actually break. And now we're looking at the molecular level. So is that going to be a physical change or a chemical change? Okay, and that's going to be a chemical change. So if we start out with one atom, we're going to add a second atom. You have to put that energy into it to form this bond. And so if you have that bond between molecules 1 and 2, and you break it, you're actually going to get some of that free energy that's going to come out of it. So when a new bond forms during a chemical reaction, what is given off? So as you're forming a new bond, you're still going to get that energy release. So if we have 1, 2, and 3, 1 and 2 are going to be broken apart, and you might need energy to break that one apart. But when you do break, you're going to get energy that's given off. And then that's going to make the second one and the third one bind together, leaving now that first one by itself. So you might need energy to break this one, but the energy that's given off is going to be more. So you're going to end up with a positive energy given off versus a negative one. So chemical change. So which one of these is the result of a chemical change? So as a new material is formed, energy is made, materials change the state which they are in, or elements are destroyed forever. So we talked about earlier in this semester that energy is never created or destroyed. So by knowing that, we know that no elements were destroyed, because we can't destroy it. That's the type of energy, so no matter is created or destroyed, which means no energy is created either. Okay? It can change forms, but it's still there in some extent. So we can get rid of those two. So now we got to make sure that we're looking at a chemical change. So out of the two that are here, is one chemical or chemical change where the other one is not a chemical change? Yeah, so if you look at here, the materials change the state that they're in. So that'd be going from like a liquid to a gas or a gas to a liquid. And that is a physical change. So that leaves us with a new material is formed. And that is the basis of a chemical change. A chemical change makes a new substance. Which of these is an example of chemical change? Water becomes vapor. Wood is charred and blackened by fire. Water evaporates from salt water, leaving behind salt crystals. Or a balloon animal suddenly pops. So real quick, we already looked at when water becomes vapor, it's just a change in the state, which is not chemical. That would be a physical change. And a balloon animal suddenly popping doesn't change the balloon at all. It changes just how it looks. Once again, that would be a physical change. And water evaporates from salt water, leaving behind salt crystals. That would be a solution. So therefore, the water evaporating, nothing's changing. It's just changing from a liquid to a gas. And the salt crystals is going from a liquid solution to a solid. So that there is a physical change. So if wood is charged and blackened from a fire, it has gone under a chemical change. So therefore, you cannot undo the damage from the fire. So anytime you see a fire or burning, it's most likely going to be that chemical change. So if you can't undo it, it's probably chemical. So now let's talk briefly about a nuclear change. So nuclear change is a change of the general structure of an atom through splitting of an atom or combining protons and neutrons to create heavier atoms. This process involves 1 million times more energy as compared to a chemical change. So you have to put a lot of energy into this for this to occur. So these are things that are not going to happen naturally. These are things that humans are putting more energy into it to get them to occur. So if you see here over on the left, we start out with a heavy element. We are going to add a neutron, and that causes it to become unstable, and it's actually going to break apart into two separate elements. So as it splits into these two elements, if you add up the atomic numbers here, plus the 3 remaining ones here, you're going to see that they are going to equal that 236. So nothing's being destroyed, it's just changing the form that it's in. If you look over here on the top, you see we're going to add a neutron into the large unstable nucleus. It's going to make it split. We're going to get a lot of energy out of it, and that is going to give us some stable elements then. So nuclear charge. What happens during a nuclear charge? Well, we're going to put in a neutron. We're going to get out energy, and we're going to get smaller, more stable particles or more stable elements out of that change. So elements are created that differ from the original reactants or from the starting elements. So if this here is our starting, you'll notice that the end products are not going to be the same. Now if you smush them all back together, they are going to equal this, but they are not. They're going to be different from the starting products. Alright, so this is the review for Unit 2, Lesson 9. If you have any questions, make sure that you are sending me a K-mail. I am here to help you. So if there's any part of this that you do not understand, make sure you're sending me a K-mail and let me know exactly which part you are having problems with so we can work together and make sure you have a good understanding of this. Thank you so much.